This is the difference between object-oriented versus functional programming. In functional programming, don't show me the interpreter. Show me the signature. Right?
Mm,
You show me
true,
the
true.
signature, I could cognitively load relatively quickly with the code, with
Is
the
doing.
responsibility of the code is, adhered to. I just butchered that sentence, but I could I get the gist of what that piece of code is trying to do. I don't have to look at the implementation details. You
Yeah.
show me the signature, and I understand what the role is.
Hey, we are back.
Odie.
All right.
So
So
what's this episode?
yeah, so this episode is going to be slightly different. I was watching, YouTube, I just browsing and stuff like that. I saw a video titled "Functional Programming is no better than object-oriented programming," and immediately I was like, "Huh?" And I saw some reactions to it. I think I saw a reaction from the Prime Gen, um, and it was interesting because most of the reactions I've seen are from mostly like an OOP standpoint, or like they understand functional programming to some extent, but they're not really like hardcore functional programmers. And I just thought, hey, this would be very something interesting that like me and Scott can like react to and see, just get what his thoughts are and just give our own take on the whole idea and the whole concept.
And why do you think that we are the ones that could provide value commenting on it? Or that's actually a rhetorical question. I'll answer it. It's because Odie and I have mad experience within the object-oriented programming paradigm of building systems, but we took the extra leap and also have mad experience building systems using FP or AKA functional programming. So we are, in theory, I would argue, uh, authoritative, right, to speak on both paradigms versus people that they've been doing object oriented for the past 30 years, right? And they haven't built a single thing in functional programming. So, yeah, let's react. I haven't seen this yet, but I'm ready.
Yeah, there we go. Yay. All right. Starting to play.
One of my most successful videos on this channel so far compares functional and object-oriented programming. This is an interesting topic and clearly not just to me. But there's more to this debate than we discussed in that episode. This is one of those debates that, to be honest, seems a little weird to me. My stance is not that I hate functional programming and love OO or vice versa, but rather that I think of each of these approaches as tools. So what are the arguments for and against OO and FP? Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. And if you haven't been here before, please do hit subscribe. And if you enjoyed the content today, hit like as well. There is no OO is best or FP is best for me. There are times when functional programming is the best choice for some things and times when object orientation is best for others.
I knew you were going to
I
stop it. I feel like we just discussed this, but other parts is you can't ignore the maintainers of the code base. If the maintainers of the code base are middle-aged dark matter developers, that is a factor. It is. They're not going to pause their life to learn a functional programming language. They demonstrated that they like stability and they have a fixed mentality. That is a factor.
okay. Let me say something. Let me say something. And yeah, I know this is the content that we're talking about, but object-oriented programming is objectively bad. Here,
I agree
let me
with you. I agree with you.
okay, so let me finish my thought.
Okay.
Why do I say this? I say this because even the most ardent, even the most ardent supporter of OOP, right, doesn't use OOP the way OOP was designed to be used. The idea of having a base class, abstract class, and everybody inheriting from it, nobody does that. What most people do is akin to something Don Syme coined object programming, separate from object-oriented programming. What's the difference between the two? Object programming is just programming with objects and interfaces and maybe traits and a few other things, right? Oh, you have a constructor, you inject things into it, and then you make calls. That's object programming. That's what most people do, right? Object-oriented programming is, oh, I have this idea, we model UML diagram and all that bullshit, and then we create classes that represent manager and sub-manager and all this other, nonsense stuff. And then when I want to save a manager, I would look for the manager object and call .save. Nobody does that. So from that perspective, object-oriented programming is just wrong, period. Object programming, on the other hand, which is bringing which removes features away from object-oriented programming, actually, and makes it a little bit more like procedural programming, right? I think that is what most people are calling object orientation today. But even I think that it's just a shift or a rollback of the industry. You get what I mean?
I get what you mean. Yes.
Yeah. Okay.
I would say
All right.
this very briefly. I believe that object-oriented programming is error-prone for delivering business solutions because it puts too much emphasis on modeling real-world systems instead of modeling the rules that the systems need to rely on.
Correct. All right, let's move on.
Most of the systems that I can remember building had some aspects of both approaches, despite the fact that I mostly still think of myself as primarily an OO programmer. This is not because of language support, but because OO ideas or functional ideas made most sense in the context of the code that we were writing at that time. I was an OO programmer in C for a long time, and some of my C code was passing around pointers to functions that I could call polymorphically.
Sorry, this is another good example. I know I keep pausing a lot, but maybe it's because my blood is all triggered and stuff like that. But this is a good example of what I mean, in the sense that he just said something. He said he was doing object-oriented programming in C. And C is not an object-oriented language, right? C doesn't have inheritance. It doesn't have what are these?
Polymorphism.
No, polymorphism is in all programming languages, even procedural languages. They all have polymorphism, right?
Okay.
Like with the whole idea of having pointers and all of that stuff.
It doesn't have interfaces?
No, C doesn't have interfaces. But what C does have is C has the ability to pass references of another object of a data structure as another data structure. You can cast pointers and stuff like that, so that the code that is using the data doesn't necessarily know that this data is slightly different now, right? C had that. C had interfaces as well with header files, where you could just include a header file and call methods, and the implementation of the method is hidden away from you. C has that as well. So those are the things he's referring to as object-oriented programming. But I think that, object-oriented programming as it was initially proposed is just bad. That the whole industry has moved away from it to some extent. So what he's currently calling object-oriented programming, in my opinion, is just object programming with objects. Oh, I have objects that encapsulate some kind of state. I'm able to call methods on it and stuff like that.
Which is the mainstream way of doing things. So I'm not disagreeing with them.
Yeah. So anyway, let's move on.
And using immutable data structures. So my C code was both OO and functional. Before I get much further in this, let me just thank our sponsors. We're extremely fortunate to be sponsored by Equal Experts, Tricentis, Transfic, and Roost. All of these companies offer products and services that are well aligned with the topics that we discuss on this channel every week. So if you're looking for excellence in continuous delivery and software engineering, then click on the links in the description below to check them out.
Odie, we should check those out and pass the word. I mean, Dave Harley, he is a contributor, right? So let's support him.
Yeah, sure, we'll do that. So, guys, if I can find the links, I'll put it in the description.
We can end up trying to score points in an argument rather than just shedding much light if we're not careful. The first thing to say may be obvious, but general purpose programming languages are general purpose. In that you can write any system in any language. There is nothing that you can do in an OO language that you can't do in a functional language, and vice versa. That's.
What do you think about that statement?
That's not true.
Why is it not? Why is it not true? My answer will blow your mind.
So let's repeat what he said. He said there's not anything that you can do in a functional language that you can't do in an OO language. And so it's not true, because one example with your F# and I would assume your Haskell is exhaustive pattern matching, right? Where imagine a switch statement that tells you that you miss a case, right? And it won't compile. Well, depending on your configuration settings, you'll get a warning, or you'll just get a flat out error if you configure your compiler that way, right? Discriminated unions, which is related to what I just said of a switch statement on steroids, which people like to call it. That doesn't really exist in C# as of like May 13th, 2023. It does exist in TypeScript, right? So I think maybe what he meant to say is, as a general purpose programming language, just straight out the box, no, they're not the same. And as a developer, you would have to add, or as a framework author, you would have to write significant infrastructure to even mimic what functional programming languages do today. And a prime example of this is, look at the last, I would argue, 5 to 6 years of the C# specification. What has it done? The majority of the features have literally adopted features from F#, okay? And that required the development team at Microsoft that works on C# to do that, not us developers, right? And yeah, you and I, Odie, we've both attempted to implement. I try to do this a lot. The maybe type, right?
Yes.
So
see. First of all, I think yes, C# copies from F#, but I would even argue that what tends to happen is that most of the ideas that are in F#, right, came from OCaml. And then other languages take those same ideas, so languages like Kotlin and so on. And only when C# sees that, oh, Kotlin has adopted this particular feature, do they now look inward and they now try to, implement it and add it to the language. And then F# programmers are like, we've been telling you about this for decades and you didn't do anything about it. Yeah, records. It's a very good example of it. But anyway, the last thing you said is actually the most accurate, in the sense that it's not that with functional languages there are new instructions you can do that you can't do in other languages. It's just that now it takes more infrastructure. You have to write a lot of things on top of it to make it happen. I remember doing Java in Android a long time ago, and this was before Java 8, where they had lambdas. There was no lambdas, and I had to simulate what a lambda is so that I can get a little bit of that functionality when I was building like Android applications and stuff like that, where I wanted to be able to pass lambdas between implementations and have the lambdas execute. There is a very powerful saying, and I'm going to repeat it here. And this is part of the reason why I said in the beginning that I have that perspective now to be able to really judge this, because what he said is actually correct. There was a story about a student who went to his professor and was showing his professor about object-oriented programming, and he was saying, hey, look at what a class is, blah, blah, blah. And the professor looked at him and was like, oh, don't you know that classes and objects are poor man's closures? And then the student went back, was like, ooh, this is true. Went, studied it, did blah, blah, blah. Went, rewrote his code with functions and closures and all this stuff, and went back to the same professor and say, hey, look, I've re-implemented this thing using closures. And the professor was like, don't you know that closures are a poor man's objects? What does that mean? It means that functions, closures, and objects are two views on the same thing. You can look at anything that you can write with a lambda, I can write with an interface. I can write with, so a lambda is just an interface with a single method, right? And if I'm able to write a new class every time I want to implement, every time I want to pass a lambda, I can rewrite any functional code that you have as objects and object-oriented. It's just that now I have to write hundreds of classes to mimic.
Right. And let's also
lambda
discuss the fact that as a human being, the more code that we write, the more errors that we're going to inject, right?
Correct.
That's just a fact, right? We are humans. And something that very briefly that we also have to take into consideration, Odie, is I wish there was a word called idiomaticity, right? But like to write idiomatic C# includes what? What do we see on job descriptions, Odie? We see on job descriptions, we need a .NET developer with experience with concurrency and multi-threaded applications. They need to know about mutexes, semaphores, locks, and whatever other word that I have to research on Wikipedia, right?
Yeah.
That is idiomatic C# when it comes to writing or implementing parallelism and all these fancy words. What's the solution in F#, Odie?
Just functions.
Just functions? Functions are stateless, right?
Yeah.
And values are immutable, right? Swipe off our hands. That's it, right? So again, this goes towards the argument of general purpose languages are not equal. They're not. When managers and lead developers that I'm providing consulting services for say, Scott, I don't understand. Why did you sprinkle this F# into our code base? What is about F# that you think is so hot? I say, well, exhaustive pattern matching. I don't have to, or the compiler tells me when I forgot a case. And I don't have to deal with this ridiculous ceremony of writing multi-threaded or whatever systems. I don't have to deal with the complexity of locks, mutexes, semaphores. I don't have to deal with any of that garbage. I don't have to deal with design patterns as much, with emphasis on as much garbage. Things are simpler, right? So that's my response. They're not created equal. In fact, F#, I would argue, was built on some of the concerns or issues that C# left out. C# addressed C# and Java. They addressed the issues of your C and C++, right? And then they either created or shown new issues that need to be addressed. And I believe that F# was the next generation of C#. I believe that. So
yeah. So in the concurrency part that you mentioned, right? I think this is a very important distinction, is that even though general purpose programming languages are exactly that, general purpose, your language highly influences how you write your code. There's no doubt about it. If you have to write infrastructure every time you want to do something, if something is painful to do in a language, you will do less of it. That's just how it is. And if something is encouraged in a language, you will do more of it. Now, where FP is really, really powerful is that we have to look at what were we trying to avoid every time a language was created. Assembly was, people were writing in ones and zero. Assembly was designed to prevent us from having to make mistakes, make mistakes on putting a 0 and a 1 and all those, making it readable. That was the whole goal of moving from machine code to assembly. Now, for moving from assembly to C, right? Remember the whole go-to considered harmful and all of that, because if you're writing assembly, you have to be doing multiple go-tos. Now, what's the issue with writing go-to statements all the time? The issue with go-to statements is that just looking at a program, you can't tell the order of execution. The order of execution is unclear because your go-to could take you to the bottom of the program and take you back to the beginning multiple times. So procedural programming languages were designed to say, you know what, let us make the flow of the program explicit, to say, well, this will happen before this, will happen before this, will happen before this. That was the whole point of C. That's what C brought to the table, right? Now, that whole flow came with it the whole concept of state and state management and figuring out what is going on. We now had OOP. OOP said, okay, instead of having one global state, right, let us break out that global state into different objects, and each object would have the methods that operate on that state. So the whole what Java and C++ brought to the table was state management, splitting the state into multiple smaller states, right? Now, what functional programming is bringing, and this is the really key part, is bringing two things to the table. The first one is it is making, first of all, it is trying to get rid of that state as much as possible, right? What do I mean by state here? State here is things that can change during the process of running your program. So we're talking properties, we're talking static values, and mutatable things are state. Functional programming is saying get rid of that state, right? That's the first thing it brings. The second thing it brings, and this is as a result of the getting rid of the state aspect, is it makes the sequence of execution irrelevant. Because if you get rid of state, then it doesn't matter the order in which things will get executed. Think SQL. SQL is a good example because SQL is actually functional. With SQL, when you write your SQL statement, the order in which the SQL engine will execute your instruction is irrelevant. So all you're doing is just describing what you are trying to do, describing the problem, and then the SQL engine, so the way the Oracle engine may deal with a particular SQL statement may be very different from the way SQL Server would deal with the same SQL statement, because there is no state involved in the program. That's what functional programming brings to the table, right? So yeah, I've totally forgotten my train of thought. You know what?
Yeah, so just to
move on.
sprinkle, I think the
Yeah.
difference is FP they like in your words, they try to attempts to remove state as much as possible, even if it means putting constraints on it. So for example, when you think about the fold operation, that is stateful. However, the construct of a fold statement, right? It's the language that takes control over it, right? It puts constraints on it so that the developer doesn't necessarily have to manage that as much. So,
in fact, in the language like Haskell is lazy end to end, meaning that even when you pass values, so let's say you call function 1, function 2, and you get A1 and A2, and then you pass those values into another function C, right? Haskell doesn't execute anything. Everything is lazily evaluated. So if in the final function you don't use a particular value, all the functions that produced that value are not called, which is mind-blowing when you think about it. But they can only do that when they ensure that there is no state whatsoever in the program, right? So anyway, yeah, I digress because we have a lot to cover.
C# does the same thing with IEnumerable, but okay.
Yes, pretty much. IEnumerable is like a functional construct. Anyway, let's move on.
It's really what general and in general purpose means. There's a difference between a general purpose language and a domain-specific language. Domain-specific languages have, by design, a narrower focus on whatever it is that their domain is. For example, SQL is a good example of a DSL, and it's great at finding a collection of records in a set, but it would be a rather poor choice for writing Space Invaders. This doesn't mean that every general purpose language is always an equally good choice for any problem. But it does mean that any general purpose language could be used to solve any problem. In computer science, this is the idea of Turing completeness, which describes the universality of computation. It may be a bad idea to write an operating system in Python, but we could. So while it may be easier to write immutable code and pass functions as arguments in Haskell, we can write code that has the same effect in C, Java, or any other general purpose language too.
Yeah, so I agree with that. I agree with that. Like, it's pretty much what we just said. You can write as close to functional code as you want to in other languages. It's just it will take more coding, it will take more abstractions to get to the same effect.
While it may be more difficult to write code with side effects in Clojure or Haskell, we can still do that if we try hard enough. So the real difference between these different paradigms is not that what they allow us to do, but how easy they make it to do the things that we want to do. This is about syntax more than capability. But syntax matters. It can change how we think about the problem that we're trying to solve. Different languages and different paradigms make some ideas easier to express. That's it, really. Let's look at a really simple example.
I think he nailed that. That's correct.
So, the first thing that comes to mind, Odie, is this is the difference between object-oriented versus functional programming. In functional programming, don't show me the interpreter. Show me the signature. Right? You show me the signature, I could cognitively load relatively quickly what the code, what the responsibility of the code is, adhered to. I just butchered that sentence, but I could, I get the gist of what that piece of code is trying to do. I don't have to look at the implementation details. You show me the signature, and I understand what the role is.
Yeah, so back to what I said earlier, right? If you think about it, the signature saying, "Oh, I take an int, I take another int, and I return a string or whatever the case may be," right? The signature is the interface between the different functional components. So as long as two separate code blocks match the same signature, they are compatible. I can swap one set for the other, which is the same thing with interfaces, right? As long as two classes or two objects implement the same interface, I can swap the object implementations, right?
Right. And when I say signature, I mean the synonyms would be show me the business equation, show me the business policy, right? They're all synonyms of a signature, right? A function signature, that is.
Yeah. Yeah.
A popular idea from functional programming is the idea of mapping, as in map and reduce. In this context, a map is a higher order function that means apply some function to each element in a collection. This is often seen as one of the preferred ways to process lists. One way in which map is deemed to be better is in terms of performance. Now, the real answer to whether maps process lists faster than loops is it depends. And it depends on a lot of things. One of the common advantages.
I'm sure that Dave Farley believes what he's saying. I have a different opinion, right?
Okay. Because you'd be surprised. I think I know what your opinion is, and I can tell you that you'd be surprised what my opinion is. But go ahead.
All right, very briefly, what's my opinion, Nodi?
Your opinion is that they are effectively the same thing in terms of performance, right?
That's not what I was going to focus on.
Okay. All right.
For loops, I believe, is the default way for a common everyday programmer to iterate through a list of items to produce the latest state of something. And for loops are the default go-to construct for reaching outside of its scope to mutate values declared above it outside of its scope, right? So within a for loop, you are mutating member variables, you're mutating properties, you're just mutating state that is not within the controlled scope of where it was declared initially, right? That is the issue with for loops. It is a construct that has total permission to manipulate things that were not initially declared within its constraints, within its scope.
There's an exception.
Okay.
Okay. What you said, I totally agree with, right? But there's an exception. The exception is for loops that do yield return.
How does that stop it from reaching outside of its scope and manipulating values on properties and member variables?
Because it's just generating new data. It's not mutating the state of
the output is new data. It still has complete permission to modify things that are outside of its scope, in addition to returning a new value.
Okay. So I get what you're saying. You are saying that for loops are inherently dangerous because for a for loop, let me just paraphrase, is that for loops have absolute access to cause mayhem and havoc to the state of your system, right?
For the implementation details that are within a for loop have permission to reach outside of the scope of the for loop, which causes maintenance concerns.
Correct. So what I was saying was that there's almost never a time that a for loop doesn't do that, right? The only exception to that a for loop goes and that a for loop doesn't manipulate state outside of the code block of that for loop is only when that for loop is generating data with yield return. That's the only exception. Any other situation where you write a for loop, you're writing it because you want that for loop to have side effects. If your for loop has no side effects, that your for loop is useless. You feel me?
Okay.
You get what I mean? So yeah. So yeah, like I said, anytime you use a for loop in code, you are manipulating states. The only time a for loop like works functionally is when that for loop is doing a yield return, right? And when you compile those for loops with yield returns, at the compiler level, what you get is not a for loop, right? At the IL level, it does some state machine gymnastics. But the point is, yeah, for loops, bad from a state perspective, yeah.
IL is the Microsoft Intermediate Language, which is the output of the interpreter before it gets executed as bytecode.
Yeah, correct.
Is that it makes concurrency easier. This is true. Writing immutable pure functions means that we can automatically parallelize them. But why is that a good idea? The naive assumption is that parallelizing like this means that we'll get the results faster. But this is almost never the case if you measure it. The problem here is that concurrency is fine, but it only improves performance when we don't need to join the results back together again. As soon as we need to rejoin the results, the costs of locks, semaphores, cache misses, and even the most efficient mechanism of all to manage that kind of concurrent join, compare and swap operations, dominates performance. Compare and swap.
I kind of agree and disagree at the same time, if that makes any sense. So I kind of agree with his assessment that concurrency in theory is supposed to be faster, but sometimes when you measure it, it's not the case, right? It might actually be just as slow as just writing a for loop and doing it that way. And the reason I kind of agree is that there's this misconception that a lot of programmers have that certain data structures are necessarily faster, right? Because of how we think about those operations. So for example, you hear people say that, oh, iterating through a linked list is faster than iterating through an array, right? Because with an array, you have to I can't remember.
Oh, it deals with big O notation. A linked list, you're only adding. I for the life of me, I can't remember the formulas of O of one. But you only do one operation to put at the either ends, right? Versus an array, you have to do a search and then inject. You always take the worst case scenario when it comes to big O notation.
Yes. So this is one of those cases where this separates a comp sci grad from an industry experienced from an industry experienced programmer. So like someone like me now who's an industry experienced programmer, I can tell you for a fact that linked lists are very, very slow compared to arrays. Arrays are lightning fast, even for operations that you're told are like more expensive with linked lists. And I'll tell you why. This will blow your mind. So one of the things they tell you is, oh, adding new elements to the end of a link, to the end of an array is harder because it has to create a brand new array. It has to copy all the contents of the old array to the new array, and then it has to now add things to the end of it. Whereas with a linked list, you only just use a pointer to the end and it's faster. However, that is true, but that's true for 8086 processors, right? That's true for Intel Pentium 2s or Pentium 3s, right? Modern day processors are wicked fast in moving arrays. The reason is that modern processors have L2 and L3 caches, meaning that your list that in quote unquote is slow, right? The processor doesn't need to reach into memory to do list up, to do manipulations on arrays. So because of it, copying arrays is much faster than manipulating linked lists, because with linked list, the processor loses that ability to predict what will happen next, right? Remember, processors are good at if a processor can predict what will happen next, processor is really, really good at that. So
you're assuming that the code base knows the processor and is coupled to it.
No. What I'm even saying is, even if the code base doesn't know about, whatever code you write, functional, non-functional, object-oriented, it has to execute on a processor, right?
Right.
And the processor has to read instructions and perform those instructions on data. Now, what I'm saying is that for most programs that deal with arrays and manipulation, right, as long as your array is not like terabytes, like if your array is into terabytes, then there's a problem. But as long as your array is like reasonably sized, array operations will beat linked list operations hands down, 100%. We can run benchmarks if you doubt me. And the reason for this, like I said earlier, is that most processors have good L2 and L3 caches. Array operations are predictable, so processors can do prefetches and things like that on them. And all the nonsense, it's not nonsense, it's actually valid. Forgive me. All the things we were taught in school about like linked list and operations and all this stuff, they apply theoretically, but in reality, that's not the case. And this brings us back to what he was saying, was that you would assume that having things run concurrently, right, means it will be faster. But in reality, it might not necessarily be the case because, like he said, cache misses and stuff like that. But my rebuttal to his statement there is that it depends. It all depends, right? So if I'm doing multiple operations in parallel, then concurrency will surely beat the cost of collapsing it, which is why GPU programming is really, really popular. Like if I was writing matrix multiplication and things like that, doing it in parallel would surely be faster. So him saying that doing things in parallel doesn't necessarily mean it's faster, I kind of disagree. It all depends. Like if you're doing multiple parallel operations and at the end you're collating them together, that cost of collation can never be more than the cost of applying all those things sequentially. Anyway, you get what I mean?
Okay.
Yeah, but the argument he made earlier, that without actually measuring these things, you can't categorically say for sure that this will always be faster, which is why it's good to always benchmark your code. Don't just say I think it's faster. Actually benchmark it and see if it's actually faster or not.
Pop is often hundreds of times slower than a single thread, for example. So you need 100 threads to get the same performance as a single thread, and then your concurrency problems would be worse. So map can be great for splitting problems into parallel processes, but will always be much slower if you need to rejoin the data again to look at it. So if you don't...
I disagree with that statement, saying that it will always be much slower. That's just wrong. it all depends on what it is you are mapping over, right? If you're doing multiple map operations, then the cost of joining it at the end isn't going to, I don't think it, again, it all depends. Context matters.
Don't gain in performance, what are the other benefits? Is the solution simpler or easier to read? I think this is a matter of taste, but I confess I don't really care very much. I see no real advantage in either representation here. As an old school programmer, I probably prefer the explicit nature of the loops a little bit, but it really doesn't really make that much difference to me.
Yeah, I could sense it. Go ahead.
If anybody has worked with me before, if anybody has known me for the last 5 years, I always send shots to Java developers. Java developers are the main genre of, oh, I just want to be explicit about it, right? What's an example of them liking to be explicit? My experience with mainstream Java developers is they don't like using whatever is analogous to the var, right?
Mm.
So var, my value equals new my type. No, they want to say my type, my value equals new my type, right? And I'm like,
Yeah.
you don't have to do that. And if you ever refactor, you have to refactor it twice as much, right? When you change the name. Yeah, but I just want to be explicit. I'm like, why are you telling the compiler what it already knows? You don't need to tell the compiler what it already knows. Do you think you're more important than the compiler? Do you really think that you're wiser than the compiler? Like, you don't. It's the compiler. Like, it has way more PhDs than you. Do you have a PhD? I bet you that compiler has dozens of PhDs that contributed to it, right? You don't
Yeah.
have a PhD, right? Anyway, like, I hate that argument. But to all the Java developers that want to be explicit, what value does that really bring? Does it bring legibility? Does it reduce the noise of the program that you're viewing through the editor? No, it doesn't. I would argue that if a programming language is meant for humans to understand, you only want to show what matters. You don't want to have any noise. You only want to see what is the essence of what's being accomplished. That's it. Anything else is a distraction. I'm done.
So from my own perspective, I think I am a little bit in the middle, right? There are certain scenarios where the first one is better. However, when you think about code is a living thing, right? So it's not just you write it and that's what it's going to be. You have to also consider how easy is it for me to change this thing if I need to change it. And that's a very, very key point. With the first example, if I needed to make this print line conditional, then I have to now start adding new lines, adding an if statement. And the more that this code gets complex, the harder it will become to understand what is really going on. Whereas with the second one, imagine if I put the map on a new line, the for each on a new line, adding a condition there would just be to put a while statement, right? A filter in between the map and the for each. And it's clear, like you said, it's clear what the intention is. Okay, I'm taking a bunch of words, I'm streaming it, I'm converting it to text, and then I'm printing it out. It flows that way. So yeah, there are certain scenarios where the first one makes sense. Like if all I'm doing inside the loop is just to maybe call into some kind of stateful system and so on and so forth. Yeah, maybe the first one makes more sense. But more often than not, the second one is clearer, right? In terms of being able to communicate the intention. Because like you said, right, compilers, they don't care. You're writing code for other programmers. The other programmers could be yourself. So anyway, let's move on.
The verbose nature of Java in this example certainly doesn't show the map in its best light here. As a result of that, I thought I'd write it in Python instead. And I have to show you this little quirk because it's funny. You can't call print from a lambda in Python, so you end up doing this instead, which is certainly worse than the loop. More technically though, Functional programmers and OO programmers talk about the value of different ideas, each picked to show off the advantages of their preferred approach usually. OO programmers talk about the value of modeling the problem. I value the high-level navigability of the problem that I get from OO. That's true. But this modeling isn't only the province of object orientation. There's a good presentation from Marco Emmerich about a functional approach to domain-driven design that I particularly enjoyed. I liked Marco's idea that the core domain of the system is functional and the I/O at the edges is always not because it has side effects.
Okay, so I think you win in that whole conversation stuff. But personally, I feel like, you know, the I/O can still be modeled functionally, right? And you see that every time we use things like async result or we use monads, right? You can still have your I/O functionally. You don't necessarily have to resort to a full-blown object orientation, you know. But like you rightly said earlier, maybe you're doing it because you have to integrate with already written systems that were designed with OOP in mind, then sure. So anyway, let's move on.
After I've stored something in a file or a database, which is shared mutable state, I really want the state to have changed. This is an interesting insight and certainly bears some relationship to how I usually design systems, even though, as I've said before, I think of my approach as more object-oriented than functional. Definitions of OO usually include abstraction, which allows us to hide unnecessary details, inheritance, defining one type of thing in terms of another, polymorphism, being able to access things of different types through the same interface, and encapsulation, which allows us to hide uninteresting detail.
So this is one of those things that is a little bit of a misnomer here. With the exception of inheritance, I feel like all the others are just general programming behavior, right? So in C, you can write abstractions, you can do polymorphism, you can also do encapsulation. You know, it's just inheritance that's just bad. And let's be real, how many times have we used inheritance writing proper OO code? The only exception is if you're writing maybe some advanced WCF library or something like that, or WPF
no.
library. Okay.
The latter part, when you're doing UI, inheritance is, I would argue, a very good way of writing or modeling a problem. When you're creating controls, sometimes it makes sense to use inheritance. We're
I
not
get
modeling
that.
we're not modeling a business domain. We're modeling a completely different problem.
Yeah, so I get that, but the problem with inheritance, and this is something that people in C++ discovered very quickly, is that sometimes your nouns, quote unquote, don't inherit from a single thing. It inherits from multiple things.
Yeah.
And then all hell breaks loose when you now add new functionality to one of the base classes, and all of a sudden the child classes doesn't know which particular method to resolve to. It's just a mess, honestly. Like,
I agree when it comes to like business policies, but I think you run into less of that when you're dealing with visual controls.
Because I get that, but with visual controls, I think one of the things that WPF does really well is this concept of why is this skipping
components?
Me? Yes, this composing rather than using composition over inheritance. Thank you very much. So rather than having all your components inherit from each other, you can have your abstract component, and then you can just include the functionalities that you want in it, right? Whether it's using
that's not WPF.
okay,
WPF thrives off of the concept of a framework element. Like I took my certification in WPF, so like I used to be on point in regards to every trivia question you could think of. I was on point, right? So I'm not trying to derail what we're discussing, but I think you and I could both agree that when it comes to the business domain, inheritance has proven to be error prone when it comes to maintainability. However, within the context of an imperative shell, I think it's less error prone, and it could be, I believe, a viable solution for presentation, and we could debate on if the data tier can leverage inheritance, which I won't advocate for that. But
Yeah.
visual presentation, like, I'm okay with it.
Okay. Okay. Let's just roll with that.
I think that most functional programmers would agree that all of these are good things, perhaps with the exception of inheritance. In fact, all of these are principles that also underpin functional programming. It's just that we describe those things in somewhat different terms. Functional programmers talk about declarative programming, which is really a form of abstraction and information hiding, and the use of types, which is based on the idea of polymorphism. Inheritance, though, is tricky because while it is clearly true that it has some strong benefits, it's also often been misused and can have some serious drawbacks. If you create a new window or button on your display, it's through inheritance that you can resize or click it. Object orientation was the technical step that really liberated code sharing. And it's no surprise that OO and the GUI came from the same place, Xerox PARC. The GUI is deeply an object-oriented inspired idea.
So I think this is where we agree with him, right? Because, like I said earlier, I remember when OO was coming out and there was a lot of hype around OO, and it was all around this whole, oh, you can build your GUI components and every button is an object and all those kind of stuff. And even though you can also do it functionally, like we see that using something like React and so on and so forth, which is really functional. But, you know, like instead of having objects on your screen and then interacting with the objects with method calls and stuff like that, in a functional aspect, your entire UI is a data structure, and then everything you do on the UI is an event that goes through a functional pipeline and then mutates the global data structure state, right? That's the functional way of doing, like, you know, UI design and all those kind of stuff. I will admit that that isn't necessarily better than using objects, but I feel like in terms of understandability or in terms of being able to reproduce bugs and figure out how your UI is built, that the functional approach is better. But yeah, it's up for debate anyway.
Non-OO programmers poke fun at OO, though. They're often poking fun primarily at inheritance. That's because you can make horrible messes with inheritance. To the extent that people who prefer simple binary answers to things will often say inheritance is bad. Of course, inheritance isn't bad. But bad inheritance is certainly bad. The big mistake in inheritance, and I'd probably say programming in general, is not to model the...
What are you thinking?
Speaking for myself, I mock object orientation, or the main. You said object oriented programming. No, you said object programming, right? That was your term. It's not so much about, inheritance. I mean, which can't be ignored. My issue with OO programmers is the vast majority of them, and I'm being real, right? I never only in, to quote this, right? Only in the object-oriented world can you be a senior developer and not know how to test your code via automation. Only in object-oriented world can you not know how to write a unit test for the code that you wrote, but you're responsible for automating solutions. True. That is an issue, right? True. So to summarize, again, I would argue that 99% of FP developers are already by default object-oriented developers. They just took the time to invest to get better at providing solutions. Those are facts, right?
Yeah.
I've never met a FP developer says, I don't know any object-oriented language. It doesn't exist. True. But that is the difference. When you write code in a functional programming paradigm, the gist of it is that code that you write in regards to the business domain is inherently testable. There is no ridiculous Django 4 design patterns None of that, dude. None. Like it.
True.
When you're ready to write a test, you can write a test because it is stateless. That's it.
Yeah. So, it's like the conversation we had with Don Simon. I was explaining how we were talking about why isn't something like property-based testing popular, and I was saying that most code bases uh, are not disciplined with state to the point where they can even write properties and they can even check for properties. Because what makes property-based testing and what makes testing in general difficult is when you have state in it. When you have uncontrolled state, it becomes almost impossible to test because you don't know how your program is going to run based on the inputs that you pass into it. Because if you think about it, let's say you have a program that takes some kind of input and spits out some output. If you want to run it in the context of a test, right? Every little interaction with the outside world has to be mocked. If you can't mock it, it won't work, right? So, and when you're mocking, you have to mock the specific branch of what could happen. And that is what makes testing difficult. If your program just took input, did some computation, and spit out output and was functionally pure, then testing is straightforward, right? You just give it input and see what the output, whether the output matches the output you expect. And then property-based testing can now make sense because now you can now say generate 100 million tests with all kinds of inputs and just see if the particular output matches the output I expect, right? I'm giving this particular property. That's what property-based testing is. And the only reason we can't get to that nirvana is because of all the state and all the craziness that comes with object-oriented programming.
Yeah. The problem that you're trying to solve well enough. Tactical programming is often at risk of being tactical crap. For example, in Java, a set inherits from a vector, and properties inherit from hash tables. This is tactical crap. A set isn't a vector. Properties are not hash tables. This was a lazy choice because it made implementing sets and properties easier. But it is nonsense, really. A set is not a vector and results in all sorts of features of sets in Java that make no sense at all. What does index of an...
So this is a prime example, Odie, of what I was saying. Object-oriented developers have a habit of believing that they're building or they're writing a system to mimic real-world objects.
Mm-hmm.
That is a flawed approach to designing solutions. So Dave Farley is like, properties are not a hash table. Well, if I can recall when I was attempting to learn Clojure, Clojure relies on, I'll just say dictionaries or hashes, right, for their
Mm-hmm.
properties. At least with FP, we're encouraged to write systems based on rules, right?
Mm-hmm.
At least that's my approach. And so Dave appears to still be attempting to write code based on real world objects. He says is a set is not a vector, even though it inherits from a vector. He says properties are not a hash table, even though it inherits from a hash table. So he's stuck in this paradigm of no, you have to program to real world nouns. We're modeling a real world system, and well, in the subject of physics, yeah, but when we're building software, we don't have to adhere to physics. We don't have to adhere to this paradigm. What we do need to adhere to is what is the policy, aka what are the set of rules in order for our solution to be compliant with what it needs to deliver. That's
Mm-hmm.
it. That's what matters. We're not in the business of modeling a system. I'll repeat that. We are not in the business of modeling systems. We are in the business of delivering solutions based on the rules that we must comply with. That's it. So I think he should reconsider his thought process about his programming approach.
Yeah.
Respectfully.
entry mean for a set? Or why would I ever wish to rehash my properties? This isn't the fault of inheritance per se. This is just poor tactical design choice.
I disagree. I think it's the fault of inheritance. I think, you know what? Let's move on.
And we can certainly make poor design choices in any language, even functional languages.
True.
I think that the key decisions in software are outside the technical detail of individual languages largely, or programming language paradigms for that matter. If you'd like to see what I mean, take a look at my training course, Better Software Faster. It describes what it takes to build high quality software and why that matters. There's a link in the description below.
You guys should check out that
In
description.
Marco's presentation, he quotes functional.
I'm going to put a link to the original video so you can just go from there.
Programmers saying functional programming is great because it has immutable data structures, a stateless programming model, pure functions, and no loops. These things make it easier to reason about your code, they say.
No loops, not quite. Stateless programming model. Okay. Pure functions, yes. But I think so all these are great, but I think the real innovation of functional programming, and this is the key idea, is functions as values. That is the jump that you have to make from someone who understands Java to a functional programmer. Is you have to see functions, you have to give functions as first-class citizens. That's it. What does that mean? It means higher order functions. It means passing functions as values. It means storing functions in variables. It means a lot of stuff, right? And that concept is what gives birth to all the other, really, really powerful things, right? Yeah, just wanted to mention that.
I disagree.
Okay. All right.
I think he captured the essence of it with his first two items: immutable data structures, stateless programming model. If you are constrained to write code with those two properties of building a system, or those two attributes of building a system, it reduces a significant portion of error proneness.
No, I get that, but I'm saying that you can have these without having functions as values. Does it make it a functional programming? Does it make it functional programming? Like if I had immutable data structures and I wrote I wrote in a stateless way in C, does it now mean that I'm a functional programmer? You get what I'm trying to say?
It captures the essence of what the functional programming paradigm is. The essence of functional programming is immutable values. It's I'm not sure about stateless programming, but you're relying on pure functions, right? I think that would be better. Well, he has that on the third item. Immutable values and pure functions reduces a lot of the complexity that we see in object-oriented systems. I would say yes.
I agree, but you still don't get what I'm saying. I'm saying that something is missing. And what's missing here is the idea that you can pass functions around as values. Functions as values, to me, is one of the core tenets in conjunction with immutable data structure, stateless programming model, and so on and so forth. I think that ability to deal with functions, aka business rules, as you said, as things you can move around, things you can manipulate, that is the leap that you have to make mentally from a normal, regular programmer or procedural programmer to a functional programmer. Now, in C, you can do that using something called function pointers, right? You can take a pointer to a function and you can pass it to different methods, and those methods will be able to invoke that function pointer to perform some kind of business logic on your behalf. I think that key part is what's missing in his definition. That's what I mean.
And I forgot what the word is. It's not high order functions. I know what high order functions are. What's the term? And Scott Blashin has an article about it. I can't think of the term where you're passing around a function, but it hasn't completed the arguments assigned to it. So you can keep passing it until it gets
Scoring.
completed. Thank you. I
Scoring.
could not think of that at all.
Yes,
So
scoring. Yeah. So
yeah.
those when I think of functional programming, that's what I think about, right? That is to me is what really separates any language from a functional programming language. You can't say a language is functional if it just uses immutable data structures and a stateless programming model, and it has pure functions and it doesn't have loops. In fact, for you not to have loops, you have to do that thing I said. You have to be able to pass in functions as values. Otherwise, okay, well, you could use recursive functions, but yeah, that's pretty much the only way you can have loops. Anyway, I digress. Let's move on.
Well, in most OO languages, I can easily make immutable data structures, program stateless code, create pure functions, and avoid loops if I choose to, even before choosing to use the functional features that have been added to most modern OO languages these days. The real value in a more functional approach to programming, as I perceive it, is really in three areas: treating functions as variables, immutability, and declarative programming. Functions as variables is a significant step. Once again, you don't need a functional language to do this, though.
Yeah,
So,
what do you want to say?
This is like very, very minor. You could tell he's stuck in the OOP world. Functions, I don't think are variables; they're values, right?
Potato, if you ask me, because I think his audience is mostly O developers, so he's trying
Okay. All right.
to explain something. Yeah.
I used to do versions of this in assembler, C, C++, Java, and Python.
Which is what I said, exactly.
But having direct language support certainly makes it nicer to use. This allows us to pass one function as an argument to another, which can then call that function.
Correct.
If you have ever come across two very similar bits of code, but that are just slightly different, like this, then this ability to pass a function as an argument is a really nice tool to use to simplify and generalize.
F that. Pause
this
it.
Is all.
F that. No. I'm going back to functions as variables. That is, I believe, is such a destructive concept to entertain, because a lot of object-oriented programmers, they think programming with variables is like the thing to do. Like there is no other way. They think it's perfectly acceptable to change the value that you assign to a symbol on the editor and not have any type of significance to some historical event that occurred. That is a huge issue. That is a huge concern. I would argue that anytime you attempt to mutate a value without recognizing an event that has taken course, you're losing context, you're losing information, and it's making it that much harder to reason about your code. And I think this is the disconnect between FP developers, who by default are OOP developers. By default, they just went the extra mile to get better at their practice, versus the ones that haven't taken that stride, that journey. Variable, I would argue, when designing systems, it causes a lot of issues that we underestimate. That's all.
I agree with you, but I don't think that was what he was alluding to. I think what he was alluding to is pretty much what you're seeing in the diagram there, right? He's just saying that the ability to take a function and pass that function to another function, that's just what he's referring to. He's not talking about, being able to change it, blah, blah, blah. He's just saying.
I understand that.
Yeah.
I think I appreciate and understand what you're saying. It's people's choice of words that they use casually that lets me know their character and how they approach problems. That's all.
True. That's a fair point. Yeah.
Also, the idea behind things like event handlers. Oh, hang on, isn't that an OO idea? Immutability is an important tool. but it's never the only tool. At some point, you want to change things because otherwise, what's the point of your code? This is one reason why I liked Marco's point that I/O at the edges of your system always has side effects. Because if it didn't, your code isn't doing anything. I agree that minimizing side effects in code can make things easier to reason about, but it's also never the whole answer, at least in the purest sense of no mutable state. At the level of whole systems, there are very few corner cases where genuinely stateless systems make any sense. And then only in very narrow contexts where code is acting as some kind of pipe that changes the data in some way. This idea is extremely valuable as part of a system, a simplifying step. But in whole systems, there's always state changing somewhere. So the idea of stateless systems is never an absolute. It is much more about where you deal with the state changes rather than eliminating them altogether. Minimizing
This
side effects is great in the right place and has been, with hindsight, an important aspect of my own approach to object-oriented design for a very long time. As Michael...
So I agree with him here. He's right in the sense that you want to minimize state effects, and so on and so forth. But I think that, and this is what I was kind of alluding to earlier, is that there has to be state in your system. That's a given. However, one of the things functional languages do really well is containing that state, right? So if you think of your maybe, like we said earlier, right? You call the database and you may or may not get back data, right? It could be null, it could be something. One of the ways that functional languages are really, really good is encapsulating that uncertainty into certainty. So rather than returning a value that may or may not be null, it returns a definite value of a representation of whether it's null or not, right? And then once you have that optional or maybe a construct, you can do things in a deterministic fashion on that value. And then the issue of whether or not it is null is just, it's no longer handled by you. You as the developer don't have to think about it. And I think that's where functional programming languages are really, really good, even for I/O operations.
So I agree with what you said. I would just respectfully enhance your statement with a result of maybe of type T, right?
Of
Any
course.
IO
Mhm.
is not secure, right? Meaning that you may not have a valid connection. That connection could be severed. And so an error can exist. If it
Mhm.
doesn't exist, then maybe you found the entry that you're looking for given the unique identifier.
Mhm.
Else, you don't have anything. And this is something that I provide as feedback and code reviews within C# code bases, where how many times have you seen this, Odie? You'll see an interface for that includes a find operation, and it just assumes that given a integer, which is another issue that I have, right? Because we're automatically creating an interface that knows that a data store has to operate on an integer, right, instead of a generic value. It just assumes that we're going to find it, right? Your public my widget find integer my key, right, is always going to return a widget. It's never ever going to uh, I don't know, not find anything. It's never ever going to be unable to connect to the server, right?
Mhm.
So I think with FP, within the framework, a lot of the frameworks for each of these languages, they they accept within the framework itself that uh, things could be errors and that you may not get what you want, and the compiler will or the constructs will constrain you to handle each of those states that a result could be in.
Mhm.
You don't really get that with your OOP languages. They don't provide you
Yeah.
with those constraints.
So there's this concept of honesty that I think Eric Meyer. Yeah, it was Eric Meyer that coined that term. He said functional languages are honest, right? Honesty here means that if something is going to happen in a functional language, right, the syntax will tell you that this is what is going on. So, for example, the example you gave, right? So rather than using optional, it will become a result of optional, right? Meaning that something could happen in the process of that call. Now, if the call is async, then it becomes async of result of optional, right? And yes, it adds more layers of complexity, but everybody is aware. You, the developer, are aware, the reader is aware, the compiler is aware that this is what could happen, right? And you just can't, those assumptions can't be thrown away, right? You have to explicitly state it. Now, granted, the languages also give you ways of bypassing the explicit check, because if you had to explicitly check for all these things every single time, it becomes very annoying. But the point of it is that the point of it is that the language itself, the tool in itself, is more honest, as opposed to languages like Java, languages like C#, where it just returns a value, and it's at runtime you will find out that, hey, this thing doesn't exist, and then all that stuff.
Odie, you know what's interesting
Well,
is FP, I believe, was introduced before OP, right? Or OOP, should I say?
yes, correct.
But then it also addresses the challenges of OOP. So it like came before OOP, and then OOP came, and it said, OOP, when you come after us, you're at least supposed to address what we didn't address as the previous generation of doing things. And maybe there's some things that you did, but there's still a lot of error proneness. Yes, I'm making that a word. And so then it comes back and says, no, I'm FP, and not only did I come before OOP, but I'm also going to address a lot of the software development concerns that OOP still hasn't addressed yet. I find that fascinating. It's kind of like a religious manifesto, right? That 3,500 years later is still like the de facto standard for how to live life. Even though like it seems antiquated and still like forward thinking at the same time. It's
Yeah,
incredible.
so one of the best examples of this was, there's this saying in computer science that all the good ideas were invented in the 70s, that we're just rethreading all those ideas. And part of the reason why we're rethreading all those ideas is because the number of programmers is doubling every 5 years. So every 5 years, all the knowledge that the previous generation had learned gets thrown away for the new shiny. And then the new shiny now becomes the norm. And 5 years later, people discover the previous old shiny and now make it the new shiny. And then it just keeps going in cycles. You see this with dynamic to static languages. We started with static, went to dynamic, came back to static, went to dynamic, came back to static. It happens every 5 years. It happens all the time. So anyway, long story short, what I'm trying to say is that those ideas, all these ideas, whether it's OOP, whether it's functional, they were all invented in the 70s. But what happens is maybe one paradigm comes and sweeps over the industry, and then we go back, But part of the reason why functional languages, like I said earlier, weren't really popular was because at the time, CPUs were very, very slow, and they didn't have as much memory.
It was
So
in the
because
late 50s, Odie. Lisp was created by John McCarthy in 1959.
no, oh, okay, yes. Okay, let's just say 50s, 60s, 70s. I know that's a very big chunk of window, but the point I'm making is that ever since the 70s, nothing has been invented that didn't exist in the previous era,
Okay.
right? Whether it's actor models, whether it's other forms of concurrency, all the good ideas were also invented back then. Anyway, the point I'm getting at is that functional programming has taken a while to mature, because at the time, you have to remember that the cost, there is a cost to functional ideas in terms of CPU usage, because at the CPU level, everything is stateful, right? And if you are writing stateless applications, there has to be that translation is not pure. The translation of your pure functional code you've written translated into a sequence of instructions that your CPU can execute, it's not a pure representation. And because of it, functional languages in the past used to take more memory, they were less efficient, and so on and so forth. But remember what I said back, 10 minutes ago, I'll be like 30 minutes ago, where we've gotten to a point where CPUs are so good now that some of the operations that we used to think are slow in the past are no longer slow, and that's why you're now starting to see the rise of functional languages. Now most of the places where our code runs is not on local hardware, it's now in the cloud, where we have data centers with servers scattered with huge amounts of memory and all those kind of things. So that's why you're seeing functional programming getting a comeback, because the world we live in today is very different from the world of the 1950s and the 1960s. So
all right, we have 1/3 of the video left, Odie. Let's try
to wrap it up.
Said to me in our chat a few months ago, object-oriented programming looks a lot like functional programming when it's done right. But whether you are developing in object-oriented fashion or functional, there are times when you want side effects. We've already talked about the obvious times when you're doing I/O of some kind. If you want to write to a file, the state that the file is in matters. Sure, you can clone an immutable snapshot of a picture of that file, but immediately you do that, it is, at least potentially, out of date because the real file on the disk is shared. Maybe someone else changed the file, or the operating system deleted it while you were in the process of dealing with your copy. Now your immutable snapshot copy of the file's wrong. The change in the file or in the database is always a side effect for another reason too. It's a side effect of working with computers that forget things when we turn them off. If I change the balance in my account, the fact that I need to store that change somewhere isn't my goal. The change in the balance is my goal, so the storage is just a side effect. Functional programming languages, of course, support this kind of thing, and some support ideas like monads that allow us to break the pure functions rule of functional programming by adding side effects. But I'd argue that this is only a special case of a more general idea. One of my favorite architectural approaches is to build message-based reactive systems. These things are like stateful actors communicating only via asynchronous messages. One reason that I like these systems quite so much is that they allow me to separate the accidental complexity and the essential complexity in my system. Let's imagine I have a bank account of some kind and I want to credit it. In my favorite actor-based approach, I may send a credit message with the value that I want to add. My infrastructure will manage the I/O. It will save the message on its way to my service, and only if the message is safely stored or clustered or whatever else will it forward it then to my service. At this point, my service will update the value of the account that it holds to create a new total balance. Is this mutable state or not? Is this OO or not? I'd say that this is a very OO way of thinking and working. My actors embody rich stateful domain models of the problem I'm solving. But here, my side effects, the storage, are isolated. More isolated, perhaps, than in some functional systems. And the change in state, an important one that must be represented somewhere, is clearly expressed and easy to understand, and can't happen without the side effects that matter having taken place. After all, I don't want my €100 to disappear, and I want to know that my total is even after a crash or a restart.
No.
So before I even start, I completely agree with him in this perspective, right? I'm a huge fan of aka.net, because again, it allows you to completely isolate the state in a way, because if you think about it, nobody can read the internal workings of an actor. In order for you to know what the current state is, you have to ask the actor, and then the actor has to reply. And that just makes for easier isolation, right? You don't have a situation where one change in the state ripples through your entire system. You know, what's your take?
Odie, here's a disclaimer. I'm drinking bourbon with Coke, so I'm going to probably be a lot more loose with what I'm saying, right? Paradigm means everything, dude. Like he talks about a file and like this I'm lacking the vocabulary right now, but this a file being locked for one individual to write to, and then it's unlocked for it to be shared and available for other people to write to. I feel like that's an old school way of viewing things, right? A paradigm means everything, I believe. And so and I know everything is very context driven, but his example is a financial like domain model, right? We're not writing to a file. We're recording events. We're recording events to a ledger, dude. Like credits and debits, man. And with that said, right, we don't necessarily, and I'm speaking for myself, and I would like a counter argument. We don't care who has access to it. We're recording an event. And a series of events, especially when it comes to a ledger, can be hydrated to the latest state, right? It's an old school model of thinking that believe that no, you have to block access to all others so I can record this. And I'm like, no, you need a symbol that represents a historical event, have a timestamp, maybe have some metadata that helps us understand the version of code that it was recorded in so that we can hydrate the state and be highly accurate. And that's it. Like
you need state. That's just the point that he's trying to make. Whether you have, in his own case, if you look at the example he gave, he showed that all the previous events are being collated, like you said. But ultimately, in order for you, see, at some point, you need to know what the state of your system is. Whether you have to do that, whether you have to do that as a result of replaying all the events or something, at some point, you want to know what the state is, right? So, because at some point, somebody needs to know, do I have enough balance to perform whatever action I'm about to do next? Which means that those events need to be condensed into state at some point.
When reading.
Whatever. When reading.
That's not whatever. When reading, state matters more than when writing. When writing, you don't have to take state into consideration because you're just pushing it to the outside world. It's when state matters and you need to consume to make informed decisions that it matters. Okay.
Yeah, but what he's saying, in essence, is that it's at that point that you have to, at that point, some computation needs to be done to collapse all those events into a single finite snapshot of your system. Because remember, when you read state, right, in between you reading the state and performing whatever decision you want to make, that state could have changed. That's his point.
Yeah, but his example is talking about writing to state. It wasn't reading to state. We can replay it, but I believe his example is writing.
Just let's go back.
The message is safely stored or clustered or whatever else. Will it forward it to my service?
Forwarded.
At this point,
that's right.
My service will update the value of the account that it holds to create a new total balance.
Those are write operations
or not? Is this OO or not?
We can write as much as we want to the outside world as events. Have a separate responsibility to aggregate those events into a meaningful state. My argument is the paradigm that he's on that believes that that's relevant, that you have to understand the state in order to do a write operation. And I'm saying that is
that's not what he's saying. That's not what he's saying at all. So what he's saying in essence is that rather than having to go through, so there are two copies. If you notice, credit 100 and 100 are two copies of the same data. The right is going to the bottom, whereas the top is just keeping track of what the current state is. If whatever happens to the current state, he can easily get it back by replaying all the contents in the database. That's just what he's saying.
Okay.
Not. I'd say that this is a very OO way of thinking and working. My actors embody rich stateful domain models of the problem I'm solving. But here, my side effects, the storage, are isolated. More isolated, perhaps, than in some functional systems. And the change in state, an important one that must be represented somewhere, is clearly expressed and easy to understand, and can't happen without the side effects that matter having taken place. After all, I don't want my €100 to disappear, and I want to know that my total is even after a crash or a restart. If I want to know what the balance is for my account, I can query this stateful copy. But I can also discard this copy and recreate it into exactly the same state as before by replaying the messages that I stored. But I can also discard this copy and recreate it in exactly the same state as before by replaying the message that I stored earlier. So once again, is this state here mutable or not? Actually, I think it's kind of both. My point here is not to sing the praises of reactive systems, well, maybe just a bit, but to point out that the line between object orientation and functional programming, and maybe even actors, is all a bit more blurry than the culture wars would sometimes suggest. Yes, it is sensible to minimize side effects in your code, whatever the nature of your code. But is there really a big difference between having a function that takes two arguments, one of them supplied by another function that defines its value, and an object with a private member variable that is used instead of the function supplied variable?
Do you get what he just said? Because what he said is precisely what I said in the very beginning. So look at it and see if you can, if you can guess what.
For what I'm capturing in his last statement, he's saying, given the context of what you're trying to accomplish, does the means to getting there really deviate that much? I think that's what I'm interpreting in what he's saying.
Correct.
And my answer is, it depends on the maintainability of it.
Okay. So if you look, so let's go over his example. In the first one, he creates a variable called variable 1. He calculates variable 2 with a constant value and gets variable 2. And then he passes both variable 1 and variable 2 into a separate function, gets the result, and just checks to see if it's the same thing. He's saying, is that different? Because that's the functional way of doing it at the top. The second way of doing it is to say, you have your variable, you create an object, you call calculate with on the calculate whatever, and that encapsulates, that keeps the state of what variable 2 is supposed to be. And then when you now finally call your my function and passing variable 1, it keeps, because it has the state of variable 2 inside the object, it's able to produce the result. And he's saying, are these two that different from each other? I think that, because it goes, like I said, it goes back to what I said earlier, when I explained that objects and, like closures are a poor man's objects and objects are a poor man's closures. You can simulate the number 2 by creating a closure that closes over the value of 3, and then you can just call the name of the function. Remember what we talked about currying? Just call the name of the function, my func, blah, 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 and pass in the first parameter. And because it already implicitly holds the value internally, it's able to compute the result. So like I said, it's just two different lenses through which you can look at how you do encapsulation and state management. But my argument is that the first one is better because it prevents you from it. In the first approach, it's no mystery that what variable 2 is going to be. In other words, if down the line people make changes to the code and so on and so forth, this function would still behave the same way. Whereas in the second one, you don't know what has happened in between calc.calculate variable 2 and calc.myfunc. Like, you literally don't know. Terrible things could have. Yeah.
That, and I would argue that the first example is 20% less lines of code than the second example.
True. So anyway, let's move on.
So think about a code base
Mm-hmm.
that an example of both paradigms. And what does 20% of a code base look like? And it would be a lot, right?
Yeah.
Which is more to maintain, more to reason about.
Also, from a debugging standpoint, right? If you put a breakpoint at the line that says int result myfunc variable 1 comma variable 2, you can easily just look at variable 1 and variable 2 and tell what the issue is, right? Whereas with the calc, maybe if it had like an internal property, you could look at the calc and then drill into the internal property. But I would argue that if the first one is written in a pure functional way, it just makes things a lot easier to reason about. Anyway, I digress. Let's move on.
Sure, the OO code here is more verbose, but that's a different question, really. All that's really going on here is how we decide to represent the sequencing of the function calls. We could debate which one's easiest to read. And
the first one is even more, I'm sorry, this doesn't matter. This doesn't really add much value. With the first example, it's less that remember when I said like 20% or whatever? It's really 3 lines of code because you don't really need the first statement, right?
True.
You can plug the literal value into the actual function and still have the same comprehension, right? So, okay.
All right.
It's on both sides. But I do believe that if we're optimizing only to minimize typing, we're already looking in the wrong place. There isn't an awful lot of typing in assembler programs after all. Optimizing for thinking is much more important. My point here is not to rubbish functional programming. My point is that I think that the debate should be a lot more nuanced than, oh, bad, functional programming good, or vice versa.
I will take objection to that. My argument is object-oriented bad, object programming good, right? Functional programming good, object programming good, object-oriented programming bad. Most people don't even write object-oriented programming. Like, they do, but it's like I said, mostly inheritance, right? Because if you think about OO, inheritance is the real innovation of OO, and inheritance is just, in my opinion, it's just objectively bad. It's objectively bad in the sense that we can do without it, and the number of times it is good versus the number of times it is bad is out of whack, right? The number of times it's good is like maybe 10-20%, but the number of times it is bad is just 80-90%. So in my opinion, get rid of it. We don't need it.
So here's my response to Dave Farley. I've never ever met a functional programmer that also knows object-oriented programming say, you know what, I prefer object-oriented. Never. Do you know any FP developer that says, nah, I don't have any constraints by my employer. I choose to write all of this in Java or C# because it's just a better solution.
It's not just choosing to write it in Java, but choosing to write it in Java with what do they call it? With inheritance and classes and rich domain models. Do you remember that whole bullshit of rich domain models where you say this employee object will have all the methods that I ever want my employee to perform?
Well, I always get confused with the term anemic domain model, right? We don't have to talk about that, right?
Yeah, sure.
But the point that I'm trying to stress is there's a reason why we're having this debate about functional programming versus object-oriented. Because we have people that literally graduated from object-oriented because they realized that there were still some pending issues or pending concerns. And so they wanted to figure out what options were available to address that. And those are the people that are now functional programmers that, if we're talking about inheritance, are a object-oriented programmer. They just took the leap, and they're more informed about
Yeah.
options to solving problems. Where the OOP folks, they never really took that leap, and I'm saying that they haven't. They haven't.
True. True.
So, yeah.
All right.
There are certainly times when functional programming is more terse, and terse can be good, but it can also be bad, ultimately depending on how easy the code is to read and understand. The last of the ideas that functional programmers often cite as the real value of functional programming is the advantage of declarative over imperative programming. I've spoken about this before. There are certainly significant advantages to expressing some ideas declaratively. My approach to test-driven development is to always aim to declare in my tests what I want the system to do, without attempting to test how it does it or say how it does it. This means that my tests are a lot more durable to change than tests that attempt to assert the implementation detail in the code.
Correct.
This is the same idea as declarative programming. If we can clearly express the outcome that we'd like to achieve without worrying about how the outcome is achieved, then great. I see lots of examples of this in examples of functional code. But to be honest, it's less obvious in people's real code as far as I can see. To be fair, my exposure to reading other people's functional code is somewhat limited. I don't read lots of it. So this may be down to the limits of my experience. But if this is the case, if the levels of abstraction that functional languages give to us are genuinely as advantageous as functional programmers tell us that they are, then shouldn't functional projects prove to be a lot faster to develop and produce fewer bugs than non-functional?
There's more factors to that, Odie.
You see?
Projects have people on it that force themselves to be relevant. I will say that in almost all of our conversations. Whenever you add human beings to a project, they have an incentive to make themselves relevant at the expense of the project itself. Okay? There's other factors to this. Everything, oh my God, Odie, everything goes back to our episode with Jamie Edwards, in which he declared that there's developer incentives that drives the results of a project, the outcome
Correct.
of a project. I mean, that should be a law. We should have a Jamie Edwards law, just like there's a Conway's law. So,
So for me, I think what he's saying, I think he's looking at it from the wrong lens. The speed of writing code isn't what is important in any project. You only write code once, quote unquote. The speed, what you should optimize for, and what functional programming languages optimize for, is how quickly can you make modifications to whatever code you've written. I would argue that most of the things we threw away from OOP, most of the things that are more functional, quote unquote, in our C# and other languages, right, are designed for modifications. Like the example I gave earlier when he showed that whole stream and stuff like that, and I was explaining that, look, adding a new construct would just be as simple as just going to a new line and saying filter, as opposed to if you wanted to modify the for loop with an if statement and all those other craziness in it. So yeah, it's not about the speed of writing programs. It's about how, first of all, it's about how quickly can you make modifications to programs. When I talk about modifications, I mean, like, think about one of the things that makes OOP programs very, very annoying is whenever a new rule, business rule is introduced, and that business rule breaks your hierarchy. And now you have to go through your entire hierarchy and change how things are inheriting from each other. That is just disgusting to me. And the reason why it's disgusting is precisely what I said earlier about the whole object-oriented programming inheritance and all that long story. So functional programming tends to be better because at the base level, you're just dealing with individual functions, and each function's state is scoped to that function. So when you're making changes, you know precisely what functions to change, and you don't need to change, the entire system. There's this famous saying about, I think one of the guys who built Erlang was saying that, The issue with object-oriented programming is you want the banana, but you have to get the banana with the monkey holding the banana, with the banana holding the tree, with the tree.
Jungle.
You have to bring in the entire jungle, right? Functional programs get rid of that nonsense. In fact, there's this video, I'll probably link it, by Brian Will, where he just said object-oriented programming is bad, and he made the case for it, right? In the sense that it's better to start with no structure and then build the abstraction later than to build in abstraction upfront and then figure out that the abstraction is wrong. I think that's the danger with OOP. With OOP, you are starting with you are starting thinking you know what the abstraction is. Whereas with functional programming, you're starting with no abstraction, just functions everywhere. And then you can reorganize and change those. You can reorganize them and create abstractions as time goes on, you know, which to me is what should take priority more than, oh, we are able to quickly write some junk up front.
This is the claim that functional programmers sometimes make. But I have looked and I don't find much evidence to support this claim. Functional programming does appear to produce fewer bugs, but the research that I've read says that this is at or close to the level of statistical noise, resulting in about a 1% fewer bug fix commits than imperative languages when measured by comparing the rate.
I know my own sources, trust me, bro, but I don't think you can use bug fix commits as a benchmark for, you know, the health of a particular, like that's what they're doing here, looking at the total number of bug fix commits and counting it. Yeah, that just seems iffy to me. It's iffy to me.
Ratio of commits that are for new things.
Let's revisit.
To fix bugs.
Let's revisit what I said early on. Show me the function signatures, right? AKA business equations, AKA business policies, right? These are all type declarations that focus on the operation itself, right? Or the suite of operations for a given domain. The majority of time that we spend, as you said, isn't writing code. It's reasoning about the code so we can make informed decisions, whether that informed decision is to write or any other action. I would think that Dave Farley would agree, if he is versed in functional programming, that that paradigm is easier to reason about what is being accomplished versus literally having to read for loops and then tracing out of scope what is mutating and then returning back. That just takes way more time, and hopefully no one disputes that. So,
yeah.
To put this into context, the data for unit testing says that you get somewhere around 58% reduction in production defects overall, though measured in a completely different way. So it may not be fair of me to make this comparison. But the difference, if any, in the quality of the code produced by functional programming versus object-oriented programming languages seems to be tiny. I think that both functional programming
that's because he didn't bring it to. That's because he left out property-based testing when it comes to the actual business domain and exposing edge cases, which why would we expect the object-oriented programmer to even be aware of those tools within the functional programming ecosystem, right? Don't get me wrong, Odie, you can speak for yourself. The majority of anomalies that I had to patch have been in the shell. They have either been within the presentation layer or they've been in the data layer. That is the bulk of the issues that have taken me significant time to address. I'm not sure what your experience is. You don't necessarily have to comment on it at this time, but yeah.
No, like for me, most of the changes that I've had to make, most of the corrections I've had to make aren't, like you said, they're usually data related and presentation related. You know, very rarely do they have to do with the business logic itself. But I think that's a side effect of the business logic being well defined upfront, right? Compared to the data access logic or the a presentation layer, because those aspects have to do with IO more often than not, and they have moving parts in them. Whereas if you're let me give you an example. So let's say we're building a calculator, for example. You find out that most of the bugs in your calculator program will be around, oh, this button is not triggering the right behavior, or the display is not wonky, or stuff like that. But the actual 1 + 1 is 2, 3 + 2 is 5. That part is the easiest to test. But secondly, that part is usually well defined. The parameters of it are well defined. The ideas behind it are well defined. The behavior is well defined, because being stateless means that, you don't have scenarios where, random things happen. Given a certain amount of inputs, given specific inputs, you know what the outputs are going to be. So, yeah, I would argue that that's the reason why. But yeah, let's move on.
No, hold up. And the other part, and I don't know, maybe you have a different opinion, Odie, is when using an FP language, especially a statically typed FP language, I tend to rely on type precision, right? AKA, I tend to rely on qualified types within my business policies or my business equations, which means that I can't just arbitrarily call an operation that takes 3 ints and returns me a result for a find operation. Well, okay, a find operation should just take 1 int. But make long story short, like what in the majority of like the business equations that I need to write an interpreter for, like there's this control flow. There's a certain state that's required to even call that operation, to even call that function. Um, and that was emphasized in my practice within functional programming versus object-oriented programming, where like the common practice that I'm aware of is you're just passing integers back and forth, regardless of if those integers really map to anything in some external database, and it's not really as intimate with the domain model. Like I find that a lot of the projects that I've been on, or a lot of code bases that I've been on, the domain model is really extremely tightly coupled to SQL Server or Oracle. They know the implementation tails. They know that the unique identifier has to be an integer. Why wouldn't it? Right?
Yeah.
And that creates a lot of refactoring opportunities once errors eventually become exposed, right?
True.
I'll just cut it short there.
Yeah. So I agree with that. Yeah.
But I also think that there are some extravagant claims made for functional programming in particular that, to me at least, don't seem to stand up to scrutiny. My conclusion is that it pays to understand both functional programming and object-oriented programming. The idea that functional programming is a step beyond object orientation in the evolution of programming languages seems just a complete misinterpretation of the history and of what's going on in reality. OO and FP are both valuable tools for building complex systems. Use them in the right context, and each will help you to build better systems, but not.
I disagree with that conclusion. Again, object programming using objects is different from object-oriented programming, which is all the extra crap that comes with it, especially inheritance. Object hierarchies, inheritance. I would say polymorphism, sure. Even encapsulation, I would even disagree with, right? Like, the idea of having state in the properties in a class, and then manipulating those properties by calling methods on the function to hide that internal state, which is what a closure is anyway. But I feel like those techniques are so error prone that we should just avoid them.
So let me try to repeat what you just said in different terms. There are challenges when we couple behavior with state. Someone
Correct.
decided that coupling behavior with state is a good idea. That
Correct.
a penny, nickel, or quarter should have behavior to it. Someone decided that, and that's been challenging.
Yes. So from my perspective, that is the problem with what he's saying. That's the problem with the whole thing, is that idea that, oh, it's fine to mix state and behavior. I think that's wrong. It's good to have objects in the sense that for certain situations objects make sense, but yeah, you don't want to use that.
Neither is the deciding factor. Thank you very much for watching. And if you enjoy my stuff, please do consider supporting our work on this channel by joining our Patreon community. There's a link in the description below.
Hey, you guys, join his Patreon. No, real talk though.
Yeah.
Is Dave Farley has contributed way more to this industry, OD, than we have. Right?
True.
We can't deny that. And
Yeah.
so maybe I got reckless with my tongue, but I do have a huge amount of respect for him. I believe that he is sincere in helping developers grow, and he's done way more than I have. So even though it sounds like I'm a critic, I haven't done half of what he's contributed to helping other people or giving value to other people, and that's real talk. So
yeah, like if you have chance, please go back, watch his video. I'm going to put it in the description below. This video is so long, I may have to clip some parts, so you may not watch everything, you may not see everything that was in the original video. Go back and watch it. But yeah, I agree with the general gist of what he was saying, but the only place I really disagree is the idea that, oh, object-oriented programming as defined based on the definition of it is actually a good idea. I think it's not true. I think most people who use object-oriented programming languages don't even write what we consider object-oriented programming languages. More often than not, what they're doing is object programming, right? Where they may encapsulate some state, but for the most part, they use like anemic, quote unquote, anemic domain models, and they use composition over inheritance, and they use more of interfaces to separate all the different components, and there's a lot of data passing from function to function. Yeah, at that point, you can't really call it object-oriented programming, because most of the core tenets of what made things like aspect or AOP, reflection,
aspect-oriented programming.
Yeah, all those craziness that comes with the original ideas of object-oriented programming. Most code bases don't use it, right? They don't do any of that stuff because it's not realistic to build easily maintainable systems that way. The idea of having a rich domain model that has all, having like a customer class that has all the different things you want your customer to do, that's just dumb. That doesn't work. It just doesn't work. I'm sorry. This industry has this object-oriented nonsense has gone on for close to 20 years. And at this point, the verdict is out. We know that doesn't work, right? Now, object programming, that works, right? The idea of having objects encapsulates maybe state here and there, having interfaces that, doing this in dependency injection, injecting different components. All that is reasonable and good and makes sense. And just because you're a functional programmer doesn't mean you should throw all those things away. In fact, I'm going to make a video on it soon. Those concepts are still valid. And I think that's where he's coming from. But that isn't what object-oriented programming was, even from the get-go. That wasn't its core design. Look at C#, for example. Most of the features that they are adding to the language is moving away from the things I just mentioned. So that's my 2 cents on it.
So Odie, do you mean to tell me that you have never ever rewritten FP code before?
Oh, of course.
Okay.
You will rewrite. See, here's the thing. Rewriting FP code isn't as devastating as rewriting OOP code. Yeah, because with FP code, right, where all the states is already managed, you just have functions. Now, the annoying part of FP is that those functions can proliferate and it can get very messy. But refactoring it is easier because you're not
Yeah.
dealing with silly abstractions that have all kinds of shenanigans and edge cases and
So
is relationships and all those craziness.
so I'm going to emphasize this again, Odie.
Mhm.
The majority of the intensive bug fixes that I've had to address have really been focused on the IO, have really been focused on the shell,
Mm.
right? The because I write business equations and then I write interpreters to those business equations, the emphasis of my labor as a professional developer hasn't really been focused on tweaking the actual domain model. I mean, it gets tweaked, but the severity of errors don't compare to the presentation or the data layer. Um, if I were to conclude to try to wrap it up on my side, one is I'm not confident that Dave Farley is a practitioner of functional programming. He
Mhm.
seems very knowledgeable, but I'm not convinced that he's experienced to be the authority on discussing that topic. And I'm not saying that he shouldn't have presented that topic, right?
Mhm.
I'm glad that it provided a platform for people like us to debate, right? But I will say that, I mean, real talk, like 20 years from now, we're going to be having the same argument about some other programming paradigm versus FP. We are.
Yeah.
And
Yeah.
FP seems more scientific. It seems more pure, right? Or more
Mhm.
pure. It seems pure. But 20 years from now, aka next generation, there will be someone that models our conversation that's going to be saying, Scott and Odie, they're so out of touch from 20 years ago. Look at this blast from the past from 2023. What were they
Mm.
thinking, right?
So, but I will say though, like just because we are functional programmers or we come from that particular perspective, doesn't mean that bad code can't be written in F sharp. In fact, or functional languages. In fact, I've seen a lot of very terrible functional code that would have been so much easier if we just used objects instead, right? Or we just used classes to model whatever it is they were trying to do. Um, but for the most part, even when that is done, even in the worst case scenario where somebody just goes buck wild with functions and writes all kinds of complex abstract things that have like crazy method signatures, right? There are easy tools that you can deterministically use to simplify the code. So in other words, when I look at a very complicated functional code, untangling it is as simple as going through an algorithm in my head and saying, change this, replace this, add this, rearrange this, move this from here to here. It's almost like a mechanical process because you're dealing with Legos, right? Each function is it's like a mini Lego. You look at the function signature. What can I extract? What can I consolidate? How can I abstract it? And all those kind of stuff. But with OOP, there's a lot less fluidity in how you can assemble your program. So yeah, that's just my point. Bad code can still be written in functional programming languages. Trust me, I know, I've seen it. But even in those bad situations, you have the tools to correct it and not as painful as with OP. That's
Yeah.
my point.
So if I were to conclude again, find me an object-oriented programmer that has also excelled or developed significant experience in functional programming that still chooses to write a business domain or a domain model in object-oriented notation. Find me one. The answer is you're not going to find one. And there's a reason for that. So people
Mhm.
that get on a platform and debate this and they lean towards object oriented and they're kind of like, they're just saying you just pick one. There's a reason why people that are functional programmers are by default object oriented programmers because they realize that there's some challenges.
Yeah.
Those are facts. So
Mhm.
that's it.
All right. So hope you guys liked this this reaction video. If you liked it, please like, subscribe. Give us a comment. Let's hear your side, your take on this. Maybe we're wrong. Maybe there are other aspects we didn't see. Just let us know.
My call to action is I'm available for hire, so hire me as a consultant.
All right.
That's it.
Cool. All right. Bye.